Hello my dear students, how are you all? Dear students, today I'm going to teach you about the alkanes in detail and the structural features which make them very special. And we will also learn very small things which are related to know about the hydrocarbons and how they are existing, where they are found and how they are named with their physical structures or with their physical properties. So let us begin. Alkanes are not something which is only found in the petrol tank of the car. They are found in many places, like some of the fruits such as apples and cucumbers have their natural waxing coating on their skin, and this waxy coating is made up of solid alkanes, means the higher hydrocarbons, which help them to retain the moisture and prevent the fruits from spoiling. And this is not the only fact about them. Some of the orchids flowers also produce alkanes to attract bees to pollinate their flowers. So they are very simple organic compounds and they consist of only carbon and hydrogen. And what is so special to be an alkane? So let us explore it. Now we see the structures of alkanes consist of hydrogen and carbon atom, and for the same reason they are called as hydrocarbons. So hydrocarbons consist of only carbon and hydrogens. So this is something about their composition. What are they composed of? And these are arranged in a tree structure, means all bonds are single. Possibly when a compound consists of carbon and hydrogen, they must be carbon-carbon bond or they can be carbon-hydrogen bonds. And what's so special about them? They are all single. Okay. The next very important thing that they have a general formula which represents the simplest ratio of carbon and hydrogen in any compound, and this is the formula CnH2n plus 2, where n means the number of carbon atoms per molecule, right? Now we are going to verify this. So what is the general molecular formula for alkanes? So you see the carbons will be n times and hydrogens will be 2 times of this n plus 2. Okay, now we see the very first member of this series is methane. Now you see the methane has only one carbon atom per molecule. So here it goes. I will be putting carbon 1 in place of n. Then hydrogen will be 2 times of 1 plus 2. So this is how we can confirm the molecular formula of methane should be C1H4 or simple CH4. Now if I put 2 carbons, so in place of n I will put 2. So hydrogen will be 2 times of 2 plus 2. So it will be C2H, 2 2s are 4 plus 2, it gives us C2H6. Similarly, you can see all the time I am putting the same molecular general formula, 6 plus 2. So it gives us C3H8. So as you see, why this formula is called as general formula, because this is the formula which is applied on all the alkanes. Means in all alkanes, the elemental ratio of carbon and hydrogen is represented by a single formula. Now this is not everything about them. We see when we collect or we classify all same compounds having single bonds in them, we will make a group, and that group is called as homologous series of alkanes. Now this is a homologous series of alkanes in which all similar compounds are classified and grouped, and they are simplest hydrocarbons. As I told you that they consist of only carbon and hydrogen, so they must be possessing same chemical properties. Now this is something which is very important to understand here, that all the compounds of the same homologous series have same chemical properties, have same chemistry, same structural features, same general formula. What three things I told you? The compounds of the same homologous series have got same structural features, same elemental ratio, and same chemical properties, means the chemical reactions. So more about them, that they differ with one another only in their physical properties. And why their physical properties are different? Because of their different molar masses. Okay, the next very important thing to understand here, that successive members, any two adjacent members like carbon number 1 and carbon number 2, carbon number 2 or 3, carbon number 7 or 8, means the closest member, the next members must be having the difference of 1 carbon and 2 hydrogens, and we call this group as methylene group. So they must have a difference of methylene group in between. So if we see the molecular structures, if we see again, we have the molecular structure CH4. It has only 1 carbon and 4 hydrogen. And if I add 1 carbon and 2 hydrogen, if I add just 1 methylene group, the carbon will be 2 and hydrogen will be 4 plus 2, it will give us 6. The next member again is with a difference of CH2 group. Here you can see all the time the successive members, the closest or adjacent members, have the structural difference of a methylene group. So this is how we keep on adding carbon atoms and hydrogen atoms, and we can find or we can determine the molecular formula or just the formula of the next alkane. Now the next thing which should be clearly understood in this class is how they are named. Now naming needs a system. As the humans are named, similarly compounds are also named. So how alkanes are named? First I tell you, alkanes are named two ways, means organic compounds can possibly have a common name, like we have our nicknames, which can be written on some special origin or maybe some special structural feature. So not all the compounds have this name, but the other name is called as the systematic name, the name which is assigned and which should be assigned as per rules and regulations. So we have a set of rules to name all the chemical compounds under International Union of Pure and Applied Chemistry. In short, we pronounce it as IUPAC. So IUPAC name is the systematic name. Okay. Now we see every name of a compound will be having two parts. This is something from the English grammar, like the first part of the name will be called as the prefix, and the later part of the name will be called as suffix. Okay, and this alk is the carbon atom, and the ending name is due to the homologous series. Now you see, as I told you, the name will be having two parts, and the starting, this alk will come from the carbon atom. How many carbons are there per molecule? And this ANE is collective suffix for all the alkanes. Like you see, all the names are ending at A and E. Why? Because all are compounds having same structural features, same elemental ratio, means they all are following this general formula, and all compounds having single bonds. So how we get to know the prefix? So if one carbon is present in the molecule, the prefix is assigned is meth. For 2 carbons, it is assigned eth. For 3 carbons, it is prop. For 4 carbons, it is but. For 5 carbons, it is pent. For 6 carbon, it is hex. For 7 carbons, it is hept. For 8 carbon molecule, it is oct. Similarly, for having 9 carbons is non, and for 10 is dec. Now this is the beginning part, no? And if we find the elemental ratio following this formula, then we will be adding this meth with A and E, and that is the collective suffix for all the alkanes. So the molecule CH4 will be named as methane. Having 2 carbons means eth will be connected with A and E. The name will be ethane. And if 3 carbons are present in the molecule, the name will be propane. If 6 carbons are present per molecule, the prefix is hex and the suffix is A and E. So the IUPAC name will be hexane. So this is how you just learn the prefixes, and the suffix is the same for all alkanes ending A and E. Now we come to discuss some of the properties of the compounds belonging to the same homologous series, and we are studying about alkanes. So very important to know about the compounds belonging to the same homologous series is that they have the same structural features. And what are structural features means? What type of bonds are present, what types of linkages are present among the elements or among the atoms of different elements, and what can be the functional group. And you just revise that functional group is the reactive side of a molecule, which can be carbon-carbon double bond, carbon-carbon triple bond, or some other non-carbon elements can also be present in the structure of organic compounds, being responsible for their reactivity, such as OH group, such as CHO group and COOH group, and I explained you about different functional groups in the previous lecture. The next thing, that they have same chemical properties. Now if their functional groups are same, their chemical properties, the chemical reactions will also be same. And a very important point about their physical properties, like all of them have same chemical properties, same chemical reactions, but the physical properties such as melting point, boiling point, the solubility or density, these properties change across the homologous series, but gradually. Like we can expect what can be the trend of the property. So this is how now we see what is the reason for this changing trend of physical properties. Like the melting and boiling points increase along the series. Like the starting members have the lower melting and boiling points. As we go to the higher members, like as we move from methane to ethane, ethane to propane, and propane to butane, we see there is a gradual increase in melting and boiling points. And this is not the only property, they become more viscous. Being viscous means the liquids which resist to flow. And I tell you, the 4 members of alkanes from carbon number 1 to carbon number 4 are generally gases. Then liquids come, then comes waxy solids. So this is how the change in the melting and boiling points is also becoming vivid in the observation that physical state is also changing, and they are becoming more viscous, means they resist to flow, and they are moving towards the solid state. And the last point is they become less flammable. Now, the flammability of a compound means how readily it catches fire, it is burned. So as we go to the higher members in the series, the flaming power is also decreasing. Like the starting member are readily catching fire, and that's why they're used as a fuel. Like, you remember when we studied about the fractional distillation of petroleum, and we got to know that mostly the fuels are hydrocarbons, and the smaller molecules means having less carbon. They are more gaseous, more volatiles, and their melting and boiling points are also very low, and they just quickly burn with oxygen and they release energy. So we see why the change is happening. Now we have observed that the change is going on, but why it is happening? Because as the molecule gets higher, it gets bulkier, it increases the forces of attraction. And these van der Waals forces or intermolecular forces, which is responsible for binding all the molecules together like making a network, it resists them in boiling at lower temperature, it resists them in flowing, it resists them in burning. So all the reasons, all the physical properties are changing across the series just due to increase in the molecular mass or size. So you see the methane molecule is smaller, but ethane molecule is a bit larger because of doubling the carbon atom. And in propane, the molecule is also getting larger in size. So as carbon atoms are increasing, they are getting more heavier, and this affects on their physical properties. Now what I explained you should just understand it, you should learn it, you should read the text from the textbook, and then just get ready for the next topic, isomerism. Thank you very much. God bless you. Khuda Hafiz.